In a survey of 1,000 people, 620 responded negatively. What interval contains the true population of those who would respond negatively? So the first thing we want to do is find the likelihood of those who responded negatively. So likelihood is probability, which we're going to change to a percent. So the likelihood is going to be, we have 620 that said negatively out of 1,000. So if we compute that, we will get 62%. Now, that actually is equal 62. That one actually equals 62. So that is our likelihood of people being negative if this sample represents a population. But because I have 1,000 people, there is a margin of error. It's not everybody, so this is just 1,000 people, which is quite a few. Pretty big survey. Now we need to find the margin of error, so I'm going to do plus or minus 100 divided by the square root of the sample size, which is 1,000. When you do that, you'll get an answer with your calculator, but you'll get an answer plus or minus 3.2%. So what that means is your answer of 62 has a plus or a minus of 3.2%. And that will be my interval for my true population, somewhere between there. So I'm going to take 62 minus 3.2, and I'm going to take 62 plus 3.2. When I do that, I'll get 58.8% all the way to, for the next one, 65 point, oops, that should be a 2 here, shouldn't it? Sorry, it should be a 2, 65.2. I messed up there. So that would be your interval for the true population, somewhere between there. Yes, we think it's 62, but there'd be a margin of error according to this 3.2. Sorry for the mistake there. What type of study is the following? You want to know if students enjoy the rally. So you ask every 10th person who came out if they liked it or not. Well, since you asked, you are doing a survey. All right, you are doing a survey. Now, if you didn't ask, let's say they walked out and you're just looking at their impressions, that's an observational study. Experiment will be a little difficult here. So be careful. You're just going to read the question. Whatever comes up, you read it. Is it a survey? Is it experiment? Or is it an observational study? A sample of normally distributed, looks like this. If the mean is 80 and the standard deviation is 6, then what percent of the data is between 62 and 92? So to do this problem, it helps to make a bell-shaped curve. 80 goes in the middle because it's the mean. Then we take steps of 6. That's how we're going to take steps of. So we're going to add 6 repeatedly on both sides. All right. And if we look at this, don't we just want to go to 92? So is at the top. We're going to stop there. Then we've got to get to 62. So aren't we going to go down until we reach 62? So here we go. Let's go down. So I'm going to minus 6 from 80, giving you 74. I'm going to minus 6 again from 70 and get 68. And then a minus again, which is right down here somewhere from it, and I get 62. So now what you see here is I have from 62 all the way to 92. You have all of this. All of that is what you want. Because, again, you have from 62 to 92. Alrighty. So, what percent is that? Well, what percent is this little category? It is it 13.25? Or 13.5, yes, 13.5%. Thinking of a different one. This one right here is 34%. This one right here is 34%. This one right here is another 13.5%. And this little sliver here, is that the 2.35%? Does that look right? And we add up all those. When you add up all those percents, you will get 97.8%. 99.35% of the data is within 62 to 92 for a mean of 80 and a standard deviation of 6. You will have to memorize these percentages. There are shortcuts. For instance, from here, from negative 2 standard deviations to positive 2 standard deviations, could you technically know that's 95? And then you could just add this. Or you could just add them all up. There's different ways. Given a sample with a mean of 120 and a standard deviation of 9, what is the z-value for a value of 100? Now, if we know the formula, we can use it. But I want to do both. I want to do what does it look like under a bell-shaped curve and the formula, even though for this problem you probably want the formula. So if we're just thinking about what this looks like, you would have a bell-shaped curve. All right, right here in the middle would be your mean of 120. And you have a standard deviation of 9. So we're going to take a couple steps out. Now, question I have is, I want 100. What side of 120 is 100 on? Is it on the left side? So let's take a look what happens here. If we take a standard deviation of 9, so I'm going to subtract 9 from this, so don't I get 111? If I subtract 9 again, don't I get 102? If I subtract 9 again, don't I get 93? Now, what we're looking for is 100. So isn't 100 right there? So if you think of standard deviations, isn't this 0? Isn't this negative 1 standard deviation? Negative 2, negative 3. So logically speaking, can you tell my answer is going to be a negative 2 point something? Probably negative 2.1, negative 2.2. So that is how you approximate. Now, for the quiz, approximation isn't what we want. We want the exact. But at least you can tell if you made a mistake. So let's do the actual formula. The actual formula is z equals, now let's write it in layman's terms. Well, z is z-score, or z-value, and that's going to equal to the value you want to know, or you're looking at, minus the mean, divided by the standard deviation. Now, there are the letters that come with the formula, but this is a little bit easier to kind of see it in more description. So let's plug it in. Z equals, the value we want, or we're given, is 100. We're going to minus minus the mean, my bad, and we're going to divide by the standard deviation. When you do that, you get negative 2.2. And does that answer match my picture reasonably? Fair? Yeah. So, one more thing. To memorize this formula, you could also do it out of logic and not even memorize the formula. Let's think logically what's happening. When you subtract a value from its mean, aren't you finding the distance from the mean? So isn't that distance 20, negative? Aren't you dividing negative 20? If I show you, watch this, it's kind of interesting. You have a distance of negative 20 divided by 9. Distance of 20, that's what subtraction means, dividing by your standard deviation. So isn't 9 going to 20 2 times with some left over? That's where this comes from. You are finding the distance and dividing by your measuring stick. So if you don't want to memorize this formula, you can kind of think it out as distance divided by your measuring stick of a standard deviation. And that will tell you how many of those there were.